We've talked about safety. It's time to talk materials. Let's get back to basics. Thanks for joining us. My name is Grant, and this is 3D Musketeers. It's now time to talk about materials because, well, some materials are a little bit different than others and actually have specific safety guidelines that you need to be aware of when you're printing them. So this is all about FDM 3D printing. If you're looking for resin, that video is coming shortly, so get subscribed. We're going to talk all about all the engineering grade resins that we're aware of and some of the things that you might enjoy about them coming at you very soon. The FDM market has been around for so long though, and that means there's a lot out there. We've got materials like PLA, ABS, PETG, TPU, ASA, Nylon, PCTG, HIPS, Polycarbonate, Polypropylene, PEKK, PEI, and Ultem, as well as conductive, wood, silk, thermochromics, tons of different stuff out there for you to be able to print awesome. That's really what this is about, right? Making awesome. We don't want you to go out and buy materials that might be a little troublesome, like ABS and ASA. They are styrene based, so you have your acrynitrile styrene acrylate and your acrynitrile butadiene styrene for ASA and ABS respectively. It is the styrene that makes that nasty smell that you're used to when you smell burning plastic. So unless you want your entire house, garage, or maker cave to smell like burning styrene, probably stay away from ABS and ASA. However, ASA is a pretty great material if you have an enclosed printer, but remember, both of those materials do need an enclosed print bed. PLA is basically what you're going to be playing around with 99% of the time. It's a great all-around material. It's got reasonably low thermo properties, so it tends to melt at about 140 degrees Fahrenheit. So here in Florida, don't leave it in your car. Unless you're actually trying to bend it over something, then do leave it in your car. It's a great way to get it to a nice, good temperature. But it stands for polylactic acid. It is actually made from corn. Yes, it is part of the byproduct of making corn syrup. And polylactic acid is a great plastic because it is biodegradable. Specifically, the most biodegradable on the market right now is Polymaker's Polyterra. Links, of course, for all of these materials will be in the description down below. Some of which are affiliate links, which help us out a lot. Polyterra is great because it really biodegrades. And if you're curious to learn more about it, we actually covered it in a whole video right here. There's lightweight PLA, which kind of foams, but that one's probably a little bit more higher grade than entry level, so that one might be one you can look at going toward. We have atomic filaments, we have Prusament, and of course, we'd be remiss if we didn't talk about Brad's Orange. And if you're wondering all about Brad's Orange, you can get it from Printed Solid, and it's their Jessie PLA. It's about $19 a kilo, and $1 of every spool purchase goes to helping the Make-A-Wish Foundation and other charities out there. And if you're wondering, why does Brad have an orange and why do I care? There'll be a card right here to Brad's episode of Making Awesome, all about Brad and his wish. This is actually one of the original spools of Brad's Orange that he made himself out when he visited Printed Solid. So that's why it is still sealed and it will remain sealed. And hey, by the way, we're almost at 1,000 subscribers, and that means a giveaway is coming soon. We're going to give away some Brad's Orange, so if you have a 3D printer or you're thinking about it, some filament might be a great addition for you. So get subscribed so you can help us get there much faster. And hey, while you're down there, leave us a like, and don't worry, we're going to have lots to talk about in the comments. PLA is a great material. It is all around, but it's actually not my personal favorite. My personal favorite, PETG, polyethylene terephthalate glycol. Probably messed that up. Don't really care. PETG. It is basically a soda bottle, right? One of your 2-liter soda bottles that is made of PET. PETG is just a glycol modified. And there is awesome PETs out there, right? You've got your recycled PETG, like something from Green Gate 3D. Again, links in the description down below. As well as atomic filament making some gorgeous colors. And we've actually covered some of those colors in some time lapses when we did for our Prusa minis Link will be right there. And the colors are absolutely gorgeous. You can get beautiful colors in PLA as well, but PET is a little bit more flexible in that it doesn't just snap into a billion pieces. It tends to yield before it snaps, and it also handles upwards of 185 degrees Fahrenheit instead of 140. So you can sometimes get away with PETG in a hot car in Florida, as long as your dashboard isn't black. We already talked a little bit about ABS and ASA, but let's dive into them just a little bit more. They are stinky, like I said, and they're the first material on this list that requires an enclosure. Yes, for small parts, you don't need an enclosure, but you will get significantly stronger parts with an enclosure. ABS and ASA do shrink. That's a problem. What happens with 3D printers is that it tends to warp and even delaminate if you don't have a high enough temperature inside of your chamber. Now, don't worry, you don't need to go run out and buy a $200,000 Stratasys Fortis machine. By the way, if you're interested in seeing really cool Stratasys printers, we have a card here where I toured their trailer, which, by the way, totally cool stuff. I still talk about that trailer and being left to my own devices around millions of dollars of 3D prints. It was pretty cool. But ABS and ASA are great materials if you need high temp and you have an enclosure. They are incredibly affordable, and ABS specifically is dirt cheap. It is one of the cheapest materials out there, and it takes blows against PLA very often at sometimes as low as $15 or less per kilogram. It can be insanely cheap because it was one of the first materials that we had in this industry because it is so easy to extrude. It's a low weight, if you will, or a low density material. It is 1.08 grams per cubic centimeter versus 1.24 for PLA. So while it still does sink in water, it's considerably less dense, which means you can run it much faster. But of course, the shrinkage factor does make it a little tough. We have a Fusion 3 F410, which is a fully enclosed printer, and with a ginormous 14-inch square heated bed, we can easily see chamber temperatures well above 50 degrees centigrade, allowing us to easily print ABS with lots of strain. Then we get into some of the more interesting materials. TPU, thermoplastic urethane, or TPE, thermoplastic elastomer. Those are your flexibles. And if you guys have seen me talk about my cane, you've seen some of the parts that we made for it, you know all about flexibles. I'll bring one of the original handle models onto screen here. This is TPU, but it is a semi-flex, so you can squeeze it, but it's gonna have a lot of rigidity. NinjaFlex is one of the most well-known TPU brands out there, and they make some incredibly soft materials. However, it's not just how soft your material is, it's how your part is designed. This one has our logo actually embedded into it in 3 different places, and all of that extra material that it needs for those top layers and bottom layers to make this puts it in a position where this is not as squishy as I wanted, so the final part actually doesn't have any logo or any branding on it. That's why when we did the Pip My Cane series on our live stream, card here of course, you can see that we added the branding there. That way we don't have it on the handle. Also, it picks up a lot of hand dirt and grime, but that's beyond the scope of this video. TPU and TPE are much harder to print out of a Bowden style machine because Bowden means that your extruder and your hot end are connected by a tube rather than one on top of the other. We'll have a video coming about different types of 3D printers here very soon, so don't forget to get subscribed and ring that bell so you actually hear us when we make videos, because we want you to hang out with us in those comments below, because, oh yeah, I always reply to them. TPU is a fun material. Give yourself some patience when you're working on TPU. It can be very tough. Out of the 4 Prusas you see behind me, only 2 of them actually like to print TPU. Why? Not a darn clue, but I don't care because we don't generally get a ton of TPU orders that quickly. So having 2 machines that you can see, we have 6, maybe 5 of the Prusas total that like TPU. Let's talk about high heat. Nylon. Nylon is polyamide, or PA. PA6, PA12, PA66, because numbers, I don't know. Nylon is a great material, but it can be very difficult to print. If you have trouble printing ABS and ASA, just don't bother. with nylon. Nylon is also the first of these materials that do require an all-metal hot end. A non-all-metal hot end is what you might find on a Creality 3D printer or one of the other low-cost 3D printers out there. If you are curious to know where we stand on some low-cost 3D printers, we actually did a video on it. There'll be a card. Nylon is a great material, though. And if you are doing very high-strength parts, you can't really beat nylon for its price-to-performance ratio. But you absolutely need a closed build chamber. Can you do it on an open printer? Yes, you can, but it's not going to be anywhere near as strong as if it is in an enclosed chamber. Nylon is known for its incredible flexibility while still maintaining a lot of its interior strength. So you can bend and flex nylon parts and they'll still spring right back to where they were. Similar to a TPU, but incredibly impact resistant as well. Speaking of impact resistance, we have polycarbonate, which is an awesome material. Again, it is best to be printed in a enclosed build chamber, but we have done it successfully on our Prusas. Just make sure that your cross-sectional area that touches the build plate is as small as possible. So if you do end up with warping, it's not going to warp across the entire surface quickly. And always, always, always make sure you have a brim. Polycarbonate is awesome. Prusa Mint makes their own blend of 11 herbs and spices, one of those including polycarbonate, so that you can print it on their open air machines. And it is awesome material. Unfortunately, no affiliate link is available for that, but hey, that's not going to stop us from really supporting Joseph Prusa and all the things that he's doing of making this industry better day after day. Of course, you've got 3DX Tech for that as well, and Polymaker. And my favorite polycarbonate right now is gotta be the Polymaker PC Lite. We love it. It prints really, really well on open air 3D printers. Links to that, of course, will be in the description down below. You've got other materials like PCTG, which I am not going to try to pronounce. It will be right here, so you can see why I'm not going to pronounce it, as well as HIPS, which is high impact polystyrene. HIPS is not a new material. It's mostly used in soluble support because it does melt away pretty easily, but it's not really all that popular anymore. It got hardcore popular and then fell off the planet as PLA became way easier to obtain. PCTG is relatively new, coming out of Ascentium. Quite frankly, it's not something I think most of the people that are looking for beginner videos are going to be looking for, but hey, if you want us to teach you all about printing with PCTG, let us know in the comments below, and heck, maybe I'll buy a few spools and get mad, do a rant about why I hate it and why it is awesome at the same time. We have polypropylene that 3DX Tech recently released, and polypropylene is great because it is what you find in a lot of packaging. When we do packaging for food businesses, by the way, if you're watching this and you are in the food packaging industry, hit your boy up. We're all about food packaging here at 3D Musketeers. We can actually print in the same materials you injection mold in, but I digress. Polypropylene, or PP as it is known, is a great renewable plastic material that is a little bit tougher to 3D print, but if you're able to do it, it's got awesome properties that you might love. Similar to Delrin in that it basically self-lubricates as it works. And yes, you can print in Delrin, but please, 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 please know what you're doing before you try that. If you overheat Delrin, it does off-gas formaldehyde, and oh Lord have mercy, that's bad news bears for your lungs. That's what they embalm people in. You don't want to be breathing that. Think about it, think about it, think about it. Then we get into what I like to call the God class of materials. PEKK, PEKK, and PEI. So that's PEKK, PEEK, and Ultem, which is PEI, polyether imide. PEEK is polyether ether ketone, and PEKK is polyether ketone ketone. Yeah. Names. These materials absolutely 100% require you to have crazy machines to print. Do not try to print Ultem on a Creality. Hell, barely even try to do it on a Prusa. They're not going to handle it very well. It is possible, but you're not going to get good prints out of it. These materials are so strong that Ultem specifically can actually handle, and I still have it from our last video, direct flame heat from a blowtorch, and is actually approved by the FAA because you can hit this with a blowtorch and it doesn't catch fire. PEI is a really, really cool material, but it is incredibly expensive. Even from companies like 3DXTech, it's almost $600 a kilogram. PLA is like 20 bucks a kilo. When you start getting above ABS in materials, you start to pay more, right? Nylon is 50 to 60. Polycarbonate can be in the 40s, but like hardcore polycarb is in the 70s and 80s. Polypropylene, I don't know off the top of my head, but PEKK, PEKK, and Ultem are well over $100 a kilo because they are incredibly strong. These are what engineers use to make rocket ships! You know, among titanium and other really cool 3D printed materials. But this is all about FDM. And yes, you can get the BASF Ultrafuse to print in metal, then get it shipped off to get it sintered, which we might do. If you want to see that, let me know. But these high strength and high temp materials, while not metal, can get very similar properties. When Ultem and PEKK and PEKK are printed properly in a heated, not just enclosed, but temperature controlled build chamber, you can get amazing quality parts out of it. I showed some of those off in the Stratasys tour video. And if you guys do want to see some raw Ultem, let me know. I'll do a quick little short video of showing you the properties of Ultem where I actually attempt to set it on fire with a propane torch and a butane torch and prove to you that it actually doesn't do it. And that's why Ultem, as long as it is certified from SABIC, is approved by the FAA to go into an airplane straight off a 3D printer, which is so cool. Then we have some of the weird stuff that doesn't really fit anywhere else, right? We've got conductive filament, we've got wood filament, we've got silks. Silk is the shiny material. If you guys saw the time lapses that we did of the snakes, you'll know this copper material. This is raw 3D printed. This is not finished. This is not painted, nothing. This was the dual screw, one of the dual screw parts that actually didn't fit. You can actually see the dual screw right there behind me. It's hanging out in the background of our videos. Some of the little things we add, little teasers in the background to previous builds that we've done. But this is silk copper. And this is its natural look. We have conductive material that, yes, while it does work, the resistance is very high. So you can like light up an LED with a 9-volt battery, but that's really about all you're gonna be able to do. And of course, there is thermochromics, which you guys saw with the Vault of Asgard that we 3D printed for Time Lapse Tuesday. And you can see there are some color striations on it because it does not get cold enough for this thing to completely go back to dark purple. But even in just holding it like this, you can see that it changes from a purple to a pink. There's wood filament as well, but wood filament is a little bit trickier to print because, of course, it has wood fiber. And there are such thing as fiber-filled materials, like carbon fiber filled. We've got carbon fiber PLA, PETG, and especially my favorite, carbon fiber nylon. One, adding carbon fiber to anything or any filled material, including wood and glow-in-the-dark, you should minimally be using a stainless steel hot end, but preferably a hardened steel, if not tungsten carbide nozzle, so that your printer doesn't just get wallered out because you're passing carbon fibers through brass nozzles. So make sure that you do change out your nozzle. And hey, if you want to know how to do that, let us know. We'll do a video all about changing nozzles on a 3D printer. Probably need a better camera to do that, but we'll make it happen for you. Carbon fiber is great for nylon specifically because it keeps it from warping so much, and it's a gorgeous black color. Or from Atomic, they makes a beautiful cherry, dark cherry red carbon fiber nylon, as well as a deep navy blue carbon fiber nylon, and I love them both. They also do it in their PETG. It is gorgeous material. Quite frankly, if all we could do is print in carbon fiber filled materials, we would, but they are considerably more expensive, like 3 times the cost of your non-filled variants. And of course, they do burn through nozzles, but boy howdy, the surface finish is gorgeous on your filled materials. But remember, start with PLA or even PETG and then work your way down the list. We'll have links to all of these in the description down below for you guys. I hope you enjoyed this. If we missed a material, let us know in the comments so maybe we can do a little follow-up video and talk about the material, because I know this is not an all-encompassing video, but hopefully you've learned a little bit, because there is so much more out there, and we want you to get educated so you can be empowered to create And 3D Musketeers, we can help you get there. And if you don't have a 3D printer, but you still want to play with these really cool materials, you can hit us up. Links will be in the description down below, where we at 3D Musketeers can make parts for you. And hey, if you let us, it'll even be a time-lapse Tuesday. But anyways, guys, thank you so much for watching. Don't forget to call your loved ones. And as always, keep making awesome. Have a good one. TPU is a fun material. Give yourself some patience when you're